the integral given is an improper integral. So the upper bound here is infinity. We do not leave it as infinity. We will just simply replace it with a and set the limit as a approaches infinity. So we integrate from 1 to a instead. And 3x minus 2 to the 3/2 is written as negative 3/2 now. It's easier to integrate this way. And after that, we set the limit as a approaches infinity. The integral of this becomes 3x minus 2. Add 1 to the exponent, we have negative 1/2. And then you divide by negative 1/2 and the coefficient of x, which is 3. And this is evaluated from 1 to a. So we take the limit as a approaches infinity. Denominator is negative 3/2, so that is negative 2/3. And that 3x minus 2 to the negative half is 1/square root of 3x minus 2, evaluated from 1 to a. We can actually pull out that negative 3/2 to make it easier. Sorry, negative 2/3. You pull this out and then you find the limit as a approaches infinity of 1/square root of 3x minus 2 from 1 to a. We have to evaluate this first and then we take the limit as a approaches infinity. So evaluated at a, we have 1/square root of 3a minus 2 minus 1/square root of 3 minus 2. So this will give us negative 2/3. Limit as a approaches infinity of 1/square root of 3a minus 2 minus 1. As a approaches infinity, this part is going to approach 0. So as a approaches infinity, you have 1/square root of a very big number, which is still very big, and the whole thing is going to approach 0. Constants, the limit of a constant is always a constant. So we have 0 minus 1, which is negative 1, and that is 2/3. For part B here, you are given the curve 1/3x minus 2 to the 3/2. The shaded region is bounded by the curve, the x-axis, the lines x equals 1 and x equals 2. The shaded region is rotated 360 degrees about the x-axis. We are to find the volume of revolution rotating about the x-axis. So we integrate pi y squared with respect to x from 1 to 2. Pull out the pi and we integrate y squared. So y is 3x minus 2 to the 3/2. When you square y squared here is 1/3x minus 2 to the 3/2. Once it is squared, it is 1/3x minus 2 to the 3. So we integrate 3x minus 2 to the negative 3 instead with respect to x, because 3 is in the denominator. This thing is in the denominator. When you bring it up to the numerator, you just have a negative exponent, and we integrate from 1 to 2. And upon integration, we have 3x minus 2 to the negative 2 over negative 2 times the coefficient of x, which is to be evaluated from 1 to 2. And that will give us negative 1/6. This is to the 2. So we are 3x minus 2 to the 2 from 1 to 2. Now we need to evaluate this. So we keep the pi, and then you replace x with 2 first. So that is 6 minus 2. That will give you 4 squared minus this. So this will become plus because this is negative here. So we have 1/6. And then 3 times 1 is 3 minus 2. So this is just a 1. And this part here is pi. And then that is 16. 16. So we have 6 times 16 plus 1/6. This can be evaluated using a calculator, and we get 5/32 pi cubic units for a volume. For part C, the normal to the curve at this point, you have a tangent. The normal is just a line like that. So you actually have a normal line that goes through this. That is the normal line. So the normal to the curve at this point, 1 and 1 crosses the y-axis at point A. We need to find the y-coordinate of A. In order to find the y-coordinate of A, we need to find the equation of the normal. And to find the equation of the normal, we need to find dy dx. So y is 3x minus 2 to the negative 3/2. dy dx is negative 3/2, 3x minus 2 to the negative 5/2 times 3. Apply the chain rule. So we have negative 9/2, 3x minus 2 to the negative 5/2. At the point 1, 1, x is 1. So the value of dy dx at x equals 1 is negative 9/2. Then we have 3 minus 2 to the negative 5/2. This is negative 9/2. That is the slope of the tangent. The slope of the normal is the negative reciprocal of this. So the slope of the normal is the negative reciprocal, negative 1/negative 9/2, which is 2/9. Then the equation of the normal, we have y minus 1 equals 2/9 x minus 1. So y here is 2/9x minus 2/9. When you move this over, it becomes positive 1. Y is 2/9x plus 7/9. This normal crosses the y-axis at the point A. On the y-axis, x is 0. So substituting x equals 0 into the normal line, we have y equals 7/9. That is the y coordinate of point A.